Okay, for number one, which expression can you substitute y in 3x plus 4y equals 7? Well, there's y equals, or 3x plus 4y equals 7. The top equation tells you what y equals. Y equals 12 minus 5x. Okay, so that means I'm going to take out the y and put in 12 minus 5x. Okay, so this one's option B. All right, option number two, the graph of a system of linear equations is a pair of lines that intersect at a single point. How many solutions does the system have? Well, if I draw a coordinate plane, there's x, there's y, okay? And a graph of a system of two linear equations. So I have maybe one linear equation there, or one line there, and I have another line there. That one intersection is their solution. Okay, so two lines can only intersect at one point. Okay. Number two, solve the system of equations. Okay, so this one, let's go ahead and plug in to see what works. Okay, I'm going to do one that's wrong and one that's right. Okay, so first, here's x and y. Alright, so I'm going to go ahead and plug into this one right here. This one looks like an easier equation. So I'm going to plug into there. X is 3, so I'm going to put in a 3. Plus 4 times y plus 4 times y is 7 equals 2. Okay, so I plug that into that equation. Looks like I get here 3 plus, and 4 times 7 is 28 equals 2. That isn't going to work. 3 plus 28 is 31 equals 2, right? That is not a solution. Okay, let's go ahead and move on then. Let's move to the one next to it. All right, so here's my x and y I'm going to try. All right, so the first x is, or the first equation is the bottom one here that I'm going to try. So x is negative 2, so I'm going to put negative 2 plus 4 times y, and y is 1, equals 2. Okay, so I'm going to do negative 2 plus 4 times 1 is 4, equals 2. Negative 2 plus 4, well, that's 2. 2 equals 2. All right, so it works for the bottom one. Now I have to make sure it works in the top one. Okay, so let's plug it into the top one. 5 times x, x is negative 2, plus y, y is 1. Equals negative 9. 5 times negative 2 is negative 10, plus 1 is negative 9. Negative 10 plus 1 is negative 9. Okay, so I plug it into both equations and they work. This is the solution then. Okay. Number 4, the graph of a system of two linear equations is a pair of lines that intersect at the origin. Which statement is true? Alright, so I'm going to go ahead and draw x and a y-axis. Two linear equations is a pair of lines that intersect at the origin. Suppose I got a line right there and another line right there, and they intersect at the origin. Well, if they intersect at the origin, the x is 0 and the y is 0. Okay, so the solution is 0, 0. Number 5. Alright, so I could do number 5 like I did number 3, okay, and plug in the options and see which one works. This one, though, is kind of set up for elimination, so I'm going to copy it over here. Okay, negative x plus 3y equals 15, x plus 7y equals 5. Looks like the x's are opposites. They have the same coefficient, opposite sign, right? So I can eliminate those. Now I got 3 plus 7 for the y's, so that's 10y. 15 plus 5 for the constants, that's 20. So I got 10y equals 20. I'm going to divide by 10 on both sides. And y equals 2. And if I look at my options, okay, the only one where y equals 2 is option D. Look, A, y is negative 9, B, y, y equals 2. Okay, sorry. So y equals 2. So I'm going to look at my options, and the only one where the y is 2 is option A. Okay, in option B, y is a -2. In option C, y is a 9. Option D, it's -9. Y equals 2, the only one where that is option A. Okay. All right, number 6. Okay, so it gives me two equations, and I have to graph. Okay, so in order to find the solution. All right, so the first equation, the y-intercept is 5, and the slope's a -1/2, so down 1, right 2, right? Down 1, right 2, down 1, right 2, down 1, right 2. So my line is going to look like this, going to the right. Always go right first. Then I finish it off to the left, up 1, left 2. The other one, y equals 2x. That's the slope is 2, right? So I'm going to put that as 2 over 1. The y-intercept is 0, so y equals 2x plus 0. Origin, and then the slope is a positive 2 over 1. That's up 2, right 1. So up 2, right 1, up 2, right 1, up 2, right 1. Okay, and then down 2, left 1. But I can already see the solution over here. It looks like the x is a 2, and then the y is a 1, 2, 3, 4. So it looks like the solution is 2, 4. Positive 2 and positive 4, which is option D. Okay, number 7. Two linear equations have the same slope and y-intercept. Okay, so same slope and y-intercept. So let's write an equation where let's write two equations where they have the same slope and y-intercept. Y equals, the slope is 4, the y-intercept is 5, and then the second one, y equals 4x plus 5. Well, those are the same lines. Okay, so if those are the same line, right, how many solutions does a system of these same linear equations have, right? Same line. It's one line right on top of each other. They're going to share many common points. Okay, number 8. This one, it's already graphed for you. Okay, so there's the y equals 2x plus 6. There's the y equals 4x. It looks like they intersect right here, where the x is 1 and then the y is 4. Okay, so this is option C, right? That intersection is 1, 4. Okay, number 9. Which expression can you substitute x in 12x plus y equals 5? Okay, so let's look at the system here. Looks like that first equation in the system, y equals x equals 6y, so I can take out the x and put that 6 minus y in there. Okay, so 6 minus y is what I can substitute for x. Okay, number 10. A graph of a system of two linear equations is a pair of lines that intersect at 5, 7. Okay, well, you have two lines that intersect at 5, 7. Let's go ahead and draw a coordinate plane. X is 5, 1, 2, 3, 4, 5. Y is 7, 1, 2, 3, 4, 5, 6, 7. Okay, so they intersect up here, right? And it's two lines, a graph of two linear equations. So two lines, so maybe you got one right there, maybe you got another one right there. They intersect at 5, 7. Okay, how many solutions? Well, they intersect at that one point. Okay. Number 11, the graph of a system of two linear equations has a pair of parallel lines with no points of intersections. How many solutions does it have? Well, the points of intersection, so no points of intersections, right? You have two parallel lines that never intersect. Okay, so that's no solution. No solutions. All right, number 12. Kim bought $100 worth of stock and gained $25 a year. Ari bought $400 worth of stock and lost $35 a year. X represent the time in years and Y represents the stock value. At how many years do Ari and Kim have the same amount of stock? Okay, so it wants at how many years, so it wants X. Okay, so what we're going to do is we're going to set both these equations equal to each other because they both equal y. So I'm going to circle these. Okay, so I'm going to do it on the side here. I'm going to set 100 plus 25x equals to 400 minus 35x. Okay, all right, so I'm going to go ahead and solve for x. I'm going to draw my line down the equal sign, minus 35, so I'm going to add 35 to both sides, add 35x. Okay, so the x is gone. Now here I have a 400 equals 25 plus 35 is 60. It's a positive 60, and I still have that 100 that I'm going to bring down. Okay, and then I'm going to get the x by itself, so I'm going to subtract 100. Okay, so I have 60x equals 400 minus 100 is 300. And then I'm going to divide by 60 to get the x by itself. So it looks like x is going to be 5. Okay, 300 divided by 60 is 5, so that's option D. Okay, all right, number 13. A system of two linear equations has no solution. What is the best description of the graph of this system? So if they have no solution, they're never going to intersect. Okay, and two parallel lines never intersect. Okay, all right, number 14 through 16 refer to this graph here. Okay, so 14 through 16 says Larissa starts with $250 and spends $25 a week. Okay, so it looks like this right here is Larissa's line. Okay, so I'm going to put an L. All right. And then Chucho starts with $30 and saves $30 a week. Okay, so the reason why I put this as line L, okay, is because she spends $25 a week. Looks like she started with $250, right, between $200 and $300. And she spends, so she's going to lose $25 a week. Chucho starts with $30, so a little less than 50 on the graph here. Okay, and then he saves $30 a week. Okay, so his savings is going to go up. Okay, choose the equation to represent Larissa's total savings. Larissa starts with $250 and then loses $25 a week. Okay, so it looks like option A has her starting at $250 and losing $25 times the number of weeks, x. Okay, 15, choose the equation to represent Chucho's. All right, so this is his right here. We said that we're going to put this as a C. So he starts with $30. So it looks like it's going to be C or D. And then he saves $30 a week. Okay, so he's going to add $30 a week into his savings. Okay. And then the last thing it says is at how many weeks do Larissa and Chucho have the same amount of money? So we look at the graph here. It looks like right here they have the same amount of money, and it wants at how many weeks? So it looks like at 4 weeks they have the same amount of money. Okay. All right, last one says choose the solution for the system. All right, so let's go ahead and start plugging in here. I think I'm going to try the smaller numbers first. It looks to me like, all right, I'm going to choose option, let's choose option C first to plug in, okay? So for option C, this is X and this is Y, right? It looks like, the easier one to choose is this one, okay? 2x plus y, so I'm going to plug that in. So for option C, 2 times negative 3 plus 11 equals 5. Okay? Alright, so I'm going to plug that one in. There's my x, negative 3. There's my y, 11. So here, 2 times negative 3 is negative 6 plus 11 equals 5. Hey, negative 6 plus 11 equals 5. So 5 equals 5. So this one's a possibility. Okay? Now I got to plug it into the top one here. Okay, so for the top one, y is 2 times y, so 2 times 11. 2 times 11 equals 2 times x, which is negative 3, minus 8. Okay, let's see if this equation works. 2 times 11 is 22, equals negative 6 minus 8. Okay, negative 6 minus 8 is a negative 14. This one does not work. Okay. 6. Just trying to real quick. 6. This one, I'm trying to figure out which one works. Negative 26, 18. I think it's that one. Negative. So this one would be negative. Okay, let's try option B. Okay. All right. So for option B, let's plug it into this one first. Okay. So option B, here's our x and here's our y. Okay. So we're going to plug it into that smaller one first just to see if it works. All right. So 2 times x. So I got 2 times 6 plus negative 1 equals 5. Oh, I'm sorry, 2 times 3. Okay, so 2 times 3 is 6 plus negative 1 equals to 5. Okay, 6 plus negative 1 does equal to 5. Okay, so you got 5 equals 5. All right, and then we're going to plug it into the top one now. Okay, so I'm going to go ahead and move over here. So I'm still plugging this one in. Okay, so 2 times y, y is negative 1. So 2 times negative 1 equals 2 times x is 3. So 2 times 3 minus 8. All right, so 2 times negative 1 is negative 2 equals 6 minus 8, and 6 minus 8 is negative 2. Okay, so option B, right, works for the bottom and the top. So option B is what you want. All right, number 18, the review questions. Choose the equation for the line below. All right, it wants the equation. It doesn't want the slope. The slope for number 18 would be 0, but the equation looks like it touches the y-axis at 5. So this is y equals 5. Okay. Let's look at number 19. Choose the equation for the line below. So it looks like the y-intercept is a positive 2. Right? So b equals 2. So looking at your options, I want a positive 2. So it's not option B, and it's not option D. All right, so the slope now should be a negative in both options left, A and C. Slopes are negative, okay? So if I get my rise over run, it looks like the slope is 1 over 2. It would be a negative 1 over 2. Okay, so the slope is a negative 1 over 2. I mean, it's always rise over run. Okay, so this one would be option A. Okay, all right, number 20. All right, so here I'm going to multiply these two exponent terms here. I'm going to multiply the 8 times 2. Okay, 8 times 2 is 16. I'm going to add the exponents on the like coefficients. So the like coefficients, I have x to the third and x to the fourth. 3 plus 4 is 7. So this is x to the 7. And then for the y, I have a positive 1. No exponent written there. Means there's a 1 there. 1 plus negative 6. 1 plus negative 6 is a negative 5. Okay. And then I see, hey, this has a negative exponent, so I'm going to rewrite it as a fraction. y to the negative 5, that's going to move to the bottom and become y to the positive 5. What's left over in the top is 16x to the 7. Okay, so this is option B. Alright, so number 21, which set of ordered pairs is y not a function of x? So we want not a function. So we're looking for repeats in x, right? Not a function. So look at option A. 1, 2, 3, 4. No repeats in the x there. Okay, so this one's a function. Okay, number 2, 2, 4, 6, 8. Okay, so again, no repeats. Number letter C, 11, 12, 13, no repeats. Okay, but option D, right here, right? There's a repeat. Okay, so it's not a function, option D. Okay, and then number 22, which of the following graphs does not represent a function? Again, not represent a function, so it looks like it's option D because look here, if I draw a vertical line right there, it hits 2 points. Okay, hits 2 points. Anywhere I draw a vertical line in these other ones, it only hits 1 point. Right? If I draw a vertical line here, right, only hits 1 point. Okay, draw a vertical line here. Anywhere I draw a vertical line, it's only going to hit 1 point. Okay, but this one hits 2. Right, so it's not a function. This one is D.